Okay, so look at this. This is running completely local on my Mac Studio. No API key, no internet connection needed, just my machine. And honestly, when I first saw this output, I was like, wait, is this actually good? Because I have been paying for Claude Max for almost a year now. So I ran them side by side, same prompts, real task, and what happened kind of surprised me. So here's the thing. Claude has been my go-to for a long time. Anytime I had a problem debugging something really weird, thinking through an architecture, that's where I went first. Then Google dropped Gamma 4, open weights, Apache 2.0 license, runs on your own hardware, and the 31 billion model is sitting at number 3 on the AI Arena leaderboard right now. Like above a lot of models you have definitely heard of. But honestly, the benchmark stuff, I don't fully trust that until I test it myself. There's also something else. When you are running this locally, nobody is watching what you are sending it. No more thinking, wait, should I be pasting this code into a cloud API? It just runs on your machine. That actually matters more than $200 a month for a lot of us. So I ran 3 tests. Real work, here's what I found. Right, first one, let's see if they can find a bug. I'm throwing a classic Python mutable default argument at them. If you have been in the trenches with Python for a while, you have definitely been burned by this one. It's that exact kind of bug that makes you question your entire career, right until you finally spot it and realize what you did. So both model caught it. Honestly, I'm not surprised. But what did caught me off guard was the depth. They didn't just hand me a patch, they actually broke down the mechanism. They both explained that Python evaluates these default once at the definition time, not every time you call the function. Both suggested the same fix using none. The real differentiator? Claude dropped a pro tip. It told me I could verify this myself by running ID on the function default to prove it's literally hitting the same object in memory. It even capped off with a hard rule. Never use mutable object as default. Gamma gave me a solid explanation, but it stayed strictly focused on the specific snippet. Honestly, round 1 is closer than I expected. If you're just looking for the fix and the logic, Gamma is right there with you. But let's see if things get messier in the round 2. Alright, so for task 2, I asked both models to architect a webhook notification API, complete with retry logic and dead letter queues. This is the real test. You need the model to actually think about failure modes, not just spit out boilerplate endpoints. Gamma's response was honestly solid. You get a clean structure, good endpoint design, and exponential backoff. It even handled the logic for separating retriable versus non-retriable errors. Honestly, if you handed this to a junior dev as a spec, they could absolutely build from it. It's complete working answer. But Claude went to a different level. It didn't just give me the basic. It suggested batch publishing and DLQ replay to an alternate URL, not just the original failing endpoint. It added per subscription retry overrides, which is huge for different integration. It even covered secret rotation with a transition window for zero downtime, key changes. But the real kicker was ordering guarantees. It addressed what happens when concurrent workers deliver events out of sequence, the exact kind of edge case that ruins your weekend 6 months into production. Neither model asked about delivery guarantees upfront. They both just defaulted to at least once, which is right for a first pass. But the gap in depth here is massive. Gamma designed a webhook system, Claude designed a one that actually survived an outage before. Alright, so for task 3, I dropped in about 150 lines of real world Python validation script and asked both the models to explain the structure and tell me what I should know before I started changing things. This is where things got weird. Gamma didn't actually see the full code. When I pasted those 150 lines into Ollama terminal, the input fragmented. The model saw pieces of code repeating, assumed the file was incomplete, and started guessing what it probably did based on the header comments. It basically hallucinated a possible answer instead of analyzing what was actually in front of it. Now, Is that a model problem or a tooling problem? Honestly, it's both. Ollama CLI isn't built for massive pastes, but the model also didn't flag the input was broken. It just confidently described it thought the code looked like. Claude, on the other hand, with browser was a different story. It got the full file and actually put it under a microscope. It caught the path resolution in the main function was fragile, meaning if you move the script, it breaks. It pointed out that the matching was case sensitive and context free. So, a pattern like filing.financial inside a random comment would trigger a false positive. It even explained how severity levels tied directly into the CI exist code. It wasn't just reading the code, it was reasoning through the ripple effect. And that's the reality of running models locally right now. Model itself might be capable, but the plumbing, the interface, and the context, it's still catching up with the cloud. Quick context on the model itself. Gamma 4 comes in four different sizes. Gamma 4 is not a full replacement for Claude. I want to be straight about that. If you want to run this yourself, Ollama commands and all three prompts are in the description. Literally just copy paste. And if you want to see me build out a full local dev workflow, Gamma for the daily work, Cloud Code for the heavy orchestration, let me know in the comments. That's the next one if you want it. Subscribe if this was useful. See you in the next one. I'm Yudi signing off. Until next one, the LLM Architect.